Dear friends, this is question number 5 from May-June 2013 exam ASL level. And the probability that a new car of a certain type has a faulty brakes is 0.008 here. A random sample of 520 new cars of this type is chosen and the number X having faulty brakes is noted. First of all, let me write the given parameters. Probability is 0.008 and the number of random samples is 520 new cars. Now the part 1 says describe fully the distribution of X and describe also a suitable approximating distribution and justify this approximating distribution. And this question is carrying 4 marks. Well, we know the two types of distribution we have seen so far, right? And first one is the binomial distribution, which we have seen in AS level, and which is given by two parameters of n and p, and the formula is this, right? And where q is the failure and p is the success. Success in this case would be we have found a faulty brake, and q meaning in this case is we did not found any faulty brake. And q is the opposite of success, which is q is equal to 1 minus p, and x is any whole number which is 0, 1, 2 up to n, right? Now the second type of distribution we have learned is Poisson distribution, and Poisson is again given by one parameter of lambda, right? So lambda is n into p, right? And the formula is this, which you already know, and where a is 2.718. That's the approximation value, approximating value, right? So lambda is equal to np. We'll submit this value here and get lambda as 4.16. Here we notice the following: n is the number of sample is 520, which is larger than 30, and secondly lambda is equal to 4.16, which is less than 5, and third is the probability is 0.008, is smaller than 0.1, right? So because of the three cases, because we have the large number of 520 and the probability of occurrence is very rare, which is 0.008. So in this particular situation, Poisson distribution would be the most suitable approximation, and that's my answer. Now let's see the part B or part 2 here. Use the approximating distribution to find P is greater than 3 here, right? It means that what? We are supposed to find the probability of getting the faulty brake which is greater than 3, right? So let's see the solution here. Faulty brake 3 would be what? A faulty brake greater than 3 would be what? We are not interested in getting the faulty brake up to 3, right? From here to here, right? We are supposed to subtract from the 100%, right? Faulty brake, no faulty brake, 1 faulty brake, 2 faulty brake, and 3 faulty brake, which is greater than leftover, but we what? Certainly P is greater than 3, right? Greater than or more than 3 faulty brake here, right? Greater than 3 faulty brake, right? Now I will simply submit the value here, right? And let me write the Poisson formula again for you. E raised to minus lambda here into lambda raised to x divided by x factorial, right? Here lambda will remain the same throughout, 4.16, 4.16, 4.16 and 4.16. Simply here we'll change the value of x here. right? X equal to 0 and put 0 here, 1 here, 1 here, 2 here, 2 and 3. Very straightforward, right? Very, very straightforward. Now we'll take the common e raised to minus 4.16 common here, and left over is this, right, in the bracket. As you can see here, 4.16 raised to 0 is again 1, and 0 factorial is 1 here, right? And this one value will go this way, and this will go here, and this will come here, right? Again, the 2 factorial is again 2, and 3 factorial is 3 into 2, which is 6 here, right? Very straightforward. Now use the scientific calculator and find the value of e raised to minus 4.16 as this value, and get this value, this one, and get value this one, right? Now it's a matter of plain algebraic calculation here. Add them together and find this value. Again multiply this and this here and get this value, and finally 1 minus 0.02852105 will give me this, and final answer would be 0.597 with 3 SF, and that's my answer. Now let's see the part B here. Part B says, get me the smallest value of n such that probability of x is equal to n, which is greater than the probability of x that's equal to n plus 1 here, right? And this question is carrying 3 marks. Let's see the solution here. Let me write the given condition here. Given condition is this, right? Now simply plug in the value of lambda here in the Poisson formula, right? Here n would go n, and this is the n here, and n plus 1 will simply come here and come here, right? Now what we'll notice here? We'll notice here that this and this is cancelling, right? Is cancelling. Now this one 4.16 raised to n plus 1, we use the law of indices as a raised to n plus 1, that's equal to a raised to n into a. You already know this, right? So we are splitting this using the law of indices here, right? Now again you will notice here this is cancelling with this. Again n factorial is cancelling with n factorial here, and the left hand side we are left over with 1 is greater than 4.16 divided by n plus 1, and now we cross multiply and get this value, and finally make n as a subject, which is 4.16 minus 1, and n is greater than 3.16. Therefore the smallest value of n would be 4, and that's my answer. Okay friends, hope you like my video, and thanks for watching my video again. Thank